Aloha, Rich Halverson here. This is ITS128, and today's October 4th. Let me share my screen. Share to. And October 21, ITS128. That's this class. That's this one. So how far have we gotten? Let's gotta go look and see here. I want to give lectures twice. Okay, we got all the way up to 6.7 loops. And was that last Tuesday? 6 days ago. Yes, very good. Why 6? Oh, it's because I didn't upload it till the next day. All right, so 6.7. So let's go back to let's go to the book. Oh, let's see where we are. Okay. All right. Ooh, we're behind. Okay, so let's get moving here. Let me open up my other book. Is this opening? Where's my book? Oh, let me just go here. Oh, let me just go here. All right. And we are in ITS128. We got all the way to 6.7 loops. Did I mean 6.7 loops or did I mean something else? Did I mean 5.7? I bet I meant 5.7. I'm gonna go here. Oh, I guess I gotta play the rest of the commercial. Six 6.7. Oh, functions with branches and loops. Okay, so we are in functions. We're not in loops. What am I? Yeah, right. Okay. Yeah, sorry for spacing out. Okay, so we're in functions. 6.7 we just finished. Let's go to 6.8. Functions are objects. And there aren't any challenge activities, but you know, and I'm not even really sure why they talk about this. This is an implementation detail of Python, of how Python implements functions, and it's just that they're objects. And kind of what that means is you can pass functions, you just like you can pass variables, or you can pass you know, objects. You can pass objects that were created from classes that you made. You can pass those, and you can also pass functions that you make. All right, 6.9. I'm starting to remember this now. Talking about common errors, copy paste errors. Let's see, where are we? 6.9. Is there anything? Yeah, there is. Copy pasting errors. That's an example. Like if you're writing a method, you know, you have a method that converts Celsius to Fahrenheit, and you're gonna make another method that converts the opposite direction. You know, it's possible you get something wrong. Runtime error. Anyway, so go through this and make sure you understand the types of common errors that can happen, and this way you can kind of think of these things first when something doesn't work. You know, these are things you pick up eventually anyway. But okay, so let's see what this challenge activity is. Using Celsius to Kelvin function as a guide, create a new function changing Kelvin to Celsius. Okay, so we're going the other direction. And so sample output with input. So the input is 283.15, and it's going to output both. It's going to output this in both directions, I guess. Okay, so anyway, and what are we supposed to do? Just fix this or something? Okay, so we're supposed to create a new method. This is the Celsius to, I'm going to do copy and paste. And this is Celsius to Kelvin. We take a Celsius value and we compute a Kelvin value. But we're not doing so. We didn't finish here, so let's finish it. Celsius to Kelvin. Oh, Kelvin, I see. Oh, yeah, no, that is right. That's Kelvin. You just gotta subtract, or what is it? You just gotta add 273 to it. Right. Okay. And so now I guess we're supposed to go the other direction. So Kelvin to Celsius is Kelvin to Celsius is going to be where we're going to bring in a value of Kelvin. So I'm going to call it Kelvin. And I'm going to say, and I'm going to be creating a new value, Celsius. CELSIUS. And so now I gotta make it the subtract 273 from both sides. And if I subtract 273 from both sides, I get minus 273.15. Then I subtract it from this side and it becomes that. And of course, that's not a valid assignment statement. It's the expression's got to be on the other side. So let's just put the expression right over on the other side here. Paste and get rid of that. So I think that's what it is. And then we're going to return the value Celsius. And that may be all I have to do. So let's see, I'm curious. Oh, what do you know? All right. What's next? Scope of variables and functions. Okay, so this is important because although there's no challenge, it's you're going to have variables declared outside the function, and you're going to have variables declared inside the function. And so when we talk about the scope of a variable, we talk about where the variable is visible. So for example, out here, okay, so there's a variable inside this method here called total inches. And total inches is not visible outside here. Whenever this method is called, then right here, this method is called. Once the method starts, then this variable total inches is created, and this calculation is calculated. The resulting value is stored there, and then that variable is taken right here, and it's multiplied by this thing, and it creates this new variable centimeters here, and then centimeters is returned. And then, so centimeters is whatever this value is, goes right here. And then once this whole thing is done, then these variables disappear. They no longer exist. They're not needed anymore. So they're gone. So when this, the only time these variables are around is when this function is executing. So anyway, so that's the idea with scope, but you can make it so something that's visible inside here is also visible outside here. Okay? You can do that by making variables global. So you can use this global, a function's variables like this and this are invisible to the code outside the function and cannot be used. Such variables defined inside a function are called local variables, and global variables, on the other hand, are visible everywhere. So here we have a variable called right allows modifying a global variable. Okay, so we have a global variable here called, or we have a variable outside here called employee name, and it's n/a. And then we can, then when we call this function here, like right, where do we call the function? Oh, we call the function right here, and then this thing executes. And the thing is this employee name is different from this employee name. This employee name here is local. So this doesn't get affected. When this thing executes, this doesn't get affected, which is why when you execute it and then you get name and then you print out employee name, it's going to print this value, not this value. See, so NA is printed. Whereas if you put this inside here, if you say global employee name, that means that this variable, if it's defined outside of the function, then use that one. So once you do here, then that's going to connect the one inside here to the one outside there. It's going to make them the same one. So when this thing gets executed, when this statement gets executed, the name gets written into this, which is the same as this, and then so on. So when it's printed, it prints out that. All right, so that's the concept. You got to pay attention to that. Okay, namespaces and scope resolution. Okay, so namespaces are, that's what they call the space that you're executing in at the time when you're inside a function. The namespace is the function's namespace and so on. Scope resolution is just basically figuring out what you mean if there's a variable that's defined both inside and outside, so on. So read that, make sure you understand that. Given the following program, select the namespace that each name would belong to. Player name. Okay, this is the program. We have player name here, and we never see it again. So anyway, I think I would call it global. Yes, because it's created outside of the functions. Role, on the other hand, it's a method that's defined. Okay, I'm gonna guess here. I'm gonna guess global. Oh, okay. Number that's this one that's inside there. That's gonna be local. And str, which is this method, that would be built in. It's a built-in function. All right, so anyway, make sure you understand that those concepts, function arguments. Okay, there's some challenges in here. Okay, arguments are simply, passing data into the method. Arguments are functions Arguments to functions are passed by object reference, a concept known as passed by assignment. A lot of different names for that. When a function is called, new local variables are created in the function's local namespace by binding names in the parameter list to the passed arguments, to the arguments that were passed, the arguments that were passed in, the values that were passed in. So it matches them up with the parameter list of the function. So here we have a function called birthday. Make this look like, sorry. We have a function called birthday, and this is the parameter. The parameter is age, and so this is, this gets connected to this. Anyway, and then here we have this is outside, and we've got this. This is a variable. It's passed in. This is called the argument. This is called the parameter, and so anyway, and again, the reason this is so the value is passed in, not the address of the variable, not access to the variable. The value of the variable is passed in. So that's why when this thing comes in, okay, so you set Timmy age to 7, you pass in 7, this is 7, you take the 7 here, you add 1 to it, and that equals 8, and that gets stored there as 8. Even though this name is the same as this name, it doesn't transfer back out to here. Okay, it doesn't transfer back out to here. Okay, so you're passing in a value. You're passing in. This is evaluated, into a value, and then that's what gets passed in. That's how it works with variables. This is Python, so let's see. These are immutable. Mutable means it's something that can be changed, and so here we're passing in, just a primitive object that's the value of Timmy's age, and that object is immutable, but there are objects that you can pass in, like a list. A list is mutable. A list can be changed. It's like an array. An array can be changed. And so if this were an array that we were passing in, and we were to do something like this wouldn't be really a valid array statement. But if we do something like this, then this thing does change. Okay, that's for something. That's for arrays and lists and so on. In this case, this is just a plain old variable. That's a value, and so that does not change. And so things that don't change are immutable. Things that can change, things that can mutate, are mutable. All right, so make sure you understand that. Here it's a dictionary, and a dictionary is mutable. You can change elements in a dictionary. You can pass in a dictionary, and then you can see this is a dictionary, and you're gonna add grades to the dictionary and so on by just passing in the reference to the. So you're passing in the reference of the dictionary. You're not sending in the whole dictionary. You're passing a reference to the dictionary, and then this method can take that reference and access the elements of the dictionary, but it can also change the elements of the dictionary. See, that's what it's doing here. So anyway, you can run that if you want to. Let's do the challenge. Write a function called swap that swaps the first and last statements of the list argument. Okay, so it's a list, so it's mutable, and so we have a list that starts out looking like this, and then we're gonna flip. We're gonna change. We're gonna exchange all in here. So and then we're gonna print it out, and it's gonna all is now at the end of the list, and here is now at the beginning of the list. And so that's what the output would look like. And so we're supposed to create a function called swap. So it's going to be def swap, and what comes in is some sort of list. So I'm going to call it some list. And so what I'm going to do is I'm going to exchange the first element with the last element. So I can do something like this. This is going to be fancy. Let's see, some list 0 gets exchanged with some list. The length of some list. No, can I just do this? Can I just do -1? Maybe I can just do that. It's an index. And then because it's Python, you can do this. And this is now I don't know if this is gonna work. So this thing exchanges the first and the last elements of this list with the last and the first elements of the list. I have no idea if this is going to work. Let me try it. Oh, it worked. What do you know? Oh, that's pretty cool. Okay, so what's 6.13 is we do have a challenge in here. Keyword arguments and you know, when you're passing out and default parameter values. So we talked about passing values to functions, and we normally, how we've been doing it is we've just you know, the parameter list is just a sequence of variable names, and then when we're calling the method, when we're calling it, we pass it a list of arguments, and they darn well better be in the same order and the same primitive type and same class type and all that as what's in the parameter list. Okay, so that's normally the way you do it, and the way we've always done it and everything. But you don't need to do it that way because you can have default values where if these were all defaults, you just wouldn't need to even include them. Okay, if these were some default values that you can define. The other thing is keyword arguments is you may not want to you may not want to pass them in the order that you that the order that they're defined in the parameter list. That you may just not like that order, and you may want to pass them in a different order because it just makes more sense. Or it's possible that the list of arguments is being, you know, generated sequentially or something, and the order it's difficult to produce in this order, so you want to produce a different. In that case, you can use keywords. And so this is an example of keywords where you would say title equals. See, so now you have to know the name of the parameters inside the method. So you know, of course, if you wrote it, then you'll know it. But if somebody else wrote it, you're gonna have to know what that person calls these parameters inside their function. But that's not that big a deal. So anyway, so this is how you can pass, and these can be in any order. See, so that's the beauty of this. So that's using keyword arguments. And okay, so if you're gonna mix keyword arguments and positional arguments, of course, the keyword arguments need to follow the positional arguments. So that burden is back on the person that writes the method. If you're gonna allow keyword arguments and positional arguments, you need to do the positional arguments first. Same holds true with default values. You can have default values, and they can be at the end, but they have to be at the end. So here, for example, and then this is the person that writes the method defines this. So let's say you have a method to print out the date, and so you input the day, the month, and the year, and then you have this fourth parameter called style, and that's going to be an integer, and let's say the default is 0, so the person doesn't need to include that parameter. So you see right here in this call, the person only included the first 3, the day, the month, the year, but not the style. So that's how that works. So the immutable default objects remain unchanged over multiple function calls. So that's nice. And so if you want mutable objects to remain unchanged over multiple function calls, then you should make a list. I mean, make copies. You make a copy of it, and then that's what you pass. So somewhere along here, you make you can make a copy on the inside. You make a copy on the inside of your method. So if you're using somebody else's method and you don't want them to mess with your original mutable object, you can just make a copy of it and send that to them. And then if you are some person who writes a method and you don't want to mess with somebody's mutable object that they pass to you, then you can make a copy on the inside. All right, so that's how you can do that, and this is all obvious stuff. All right, let's see what this is. Okay, so this is started up. Type the output. So we're gonna print these 3. So we're gonna print A, and then we're gonna print a slash, and then a B, a slash, and a C, and a slash. A, B, C. Okay, so you notice the parameters are in a different order. We're using the keyword way of passing parameters, and so the first thing that's going to output is A, which is 8, and then we're going to I guess put a slash, and then we're going to print the B, which B is 2, and then we're going to put a slash, and then we're going to put the C, which is 9. And I guess we're going to have to do this. Okay, let's do the hardest one. Okay, we got some defaults in here. Okay, so the first one we're going to print we're going to print A, C, and then B. Oh, clever. Okay, first we're going to print A. In the first one, the A is 9. And then we're going to print C. What is C? C is not defined here, so we use the default C. Oh, that's 5/5. And then we're going to print B. And what's B? Oh, B is defined as 2, so I'm going to do it 2. And then we're going to do this again, because we call show again. First thing we're going to print is A again, and A is going to be 1. And then we're going to print C, and C is 8. And then we're going to print B. And B is not defined here, so we go to the default, and that's 6. Enter. All right. Very good. Okay, what's this one? Write a function called number of pennies that returns the total number of pennies given a number of dollars and optionally a number of pennies. Okay. So if you have this, if that's the amount of money that you have, then the input is $5.06. Got it. Okay. So the first thing you enter, is it's a weird function. Okay. So I'm going to do this. Oh, I see. I think I get this. Okay, so I'm going to make a method called number of pennies, def number of pennies, and I'm going to do dollars. So what's coming in is dollars, and then optionally what comes in is pennies. So pennies, and I'm going to say equals 0. And then I'm going to do total pennies equals dollars times 100 plus pennies. And then I guess I'm just going to return total pennies. All right, I guess I'm going to see if this works. Say, I'll be right back. I got to turn the dryer off. Okay. All right, so it looks like this. So it looks like we got this one. All right, what's this last one here? Write a split check function that returns the amount that each dinner must pay to cover the cost of the meal. The function has 4 parameters: bill, people, tax percentage, and tip percentage. Okay. And so the tax or tip percentages are optional and may not be given when, and they might not be given when calling split check. So those are going to be defaults. And then use default parameter value. Okay, so that tells what the default parameters are: 15% for tip and 9% tax. All right, awesome. Okay, oh yeah, 9%. Okay. Assume that the tip is calculated from the amount of the bill before tax. All right. So I need to make a function called split check. Okay. Def split check. And there's going to be a bill, and there's going to be a people, number of people, and there's going to be a tax percentage, which defaults to 0.15, and a tip percentage equal to 0.09. Okay, and I guess I could be consistent with my, they like you to get this. Okay, so that's the name, that's the starting of it. And I'm supposed to take, oh, what's this hint? What is this hint here? It says, calculate the amount of tip and tax, add to the bill total, then divide by, oh, okay. So, so I'm going to say bill total equals bill plus hold it. Come on. This has got to be point. Oh, what's the order? Does it matter? No, does it really matter? I don't think it matters, but I'm going to do it in this order. Tax percentage is first. So this should be 0.09. And this should be 15. And so the bill is, and then so the tip is going to be, bill times tip percentage. So that's what the tip is going to be, the bill times the tip percentage. So it's going to be 15% of the bill. And that gets added onto the bill. And then we got to do some tax. So I'm going to do this. Bill before tax is that. And then bill total equals bill before tax plus the bill before tax times the tax percentage. Okay, so and so we take how much the bill is, and then we figure out what the tax is. The tax is the bill before tax times the tax percentage. This will be calculated first because multiplication has precedence over addition. So that'll be calculated. So this is going to be some small number that's the tax, and then that's going to be added onto the bill. And so the bill is that right? Is that? I guess it matters if you include the bill, if you include the tip on your credit card, you're going to have to pay tax on that. Right, so that's how this is. If you were actually to give the tip in cash on the table, then you wouldn't have to pay tax on that. All right. Anyway, this is how they want it. So and then so now I'm going to return bill total. Return bill total. So I don't know. This might work. Let's see. All right. Oh, I forgot to divide by the number of people. So bill per person equals bill total divided by 4. No, people. Divided by people. And then I'm going to return bill per person. Okay. How's that? Right. What is it not liking? Oh, I must be doing something wrong. I must be doing something wrong. Okay, I didn't do the hint right. Calculate the amount of tip and tax. Add to the bill total. Okay, what does it say? The tax or tip percentages are optional. Assume the tip is calculated from the amount of the bill before tax. Oh, tip before tax. Okay. Tip. Oh, that's what I did. Tip before. Tip. All right, and what am I getting wrong here? Cost per dinner. All right, it's time for me to look at see what the thing says. 613. Don't want to waste too much of your time here. And I am tax percentage 0.9. Tip percentage 0.5. Bill equals tips. Tax. Okay. Bill per. Okay. Bill. Okay, this is the problem. Both the tax and the tip are computed just on the bill. And what I did was I computed the tax on the bill plus the percentage, or plus, on the bill plus the tip, like how it would be in on a charge card. So it's not how it would be in a charge card. It would be where you give the tip separately in cash and you pay for the. Okay, so anyway, so let's just do the tax. Tax is equal to bill times. Ooh. Yeah, I named these wrong too. Anyway, so the tax is just going to be I did this wrong. Tip is that. And tax is bill times tax percentage. And then the bill total. Bill total is bill plus tip plus tax. Okay. All right. And then so there, I think this will do it. Bill total. Okay, so let's see what this is. All right, well, gee whiz. Okay, so 614. Arbitrary argument lists. Sometimes the programmer doesn't know how many arguments the function requires, and so a function definition can include a asterisk args parameter that collects optional positional arguments into an arbitrary argument list. And then I guess you can probably access it by looping through, or maybe indexing. Must be a list. It's a list. And so are there any, this is 614. There are no challenges in there. So, make sure you understand that. And multiple function outputs, you can do that. See, how's this going to work? Ah, here we go. See, when we return, we just do this. And that's going to be some sort of, so you call it like this. That's how you call it. You're expecting back two values. And so here's the definition. Execute, and then it returns two values. Okay, so that can be convenient. All right, 16, no activities here. All right, so you can look at that. I think there's a challenge in here. So here we're just going through a real life examples to pique your interest. In case maybe you're interested, Python is a programming language that is probably used mostly. It is used mostly by people that aren't professional programmers. They're engineers, or they're something similar that use programming, and they just use Python programming as a tool. It's like you use your calculator as a tool. So these are kinds of examples. And so if you want to do some sort of repetitive calculation and do the same kind of processing on a list of data, you can use Excel or you can use Python. It's just another tool. All right, so let's look at this. Define a function, compute gas volume, that returns the volume of a gas given the parameters of pressure, temperature, and moles. Use the gas equation. Pressure times volume equals N, which is the number of moles, times R, which is just some sort of gas constant. It's just this number here. That's R. And then T must be temperature in Kelvin. And so, and P is the pressure in pascals. Pascals. P is the pressure in pascals. Okay, so so we're going to input the gas pressure, then the moles, and the temperature, and then the volume. And we're going to then we have to write this method here, this function that's going to compute compute gas volume, which returns the volume of gas. Is this what we're returning? That must be what we are returning. So I'm going to assume that's what we are returning. So I'm just going to write a function that reads in, that takes in these things: the number of moles, it's supposed to output volume. Oh, this is volume. Oh, so that means we have to divide by P. This is PV equals this. And so if we just want V, means we divide this side by P and we divide this side by P, and we just end up with V on the left. And then, okay, so I'm going to say def compute gas volume, left parentheses, right parentheses. And so I'm going to say gas pressure is the first thing that comes in, and that's going to be P in pascals. And the next thing that comes in is gas temperature, which is T in Kelvin. And the third thing is gas moles, which is N, number of moles. Colon. So that's what's coming in. Oh, do we doing any default? All right, and then we're going to compute. I'm going to say PV equals N n times r. What's r? Oh, the constant, gas constant. This is this. I'm going to say, all right, I guess I got to do global gas constant. And then R is gas constant. So that's what, so I'm going to do this just to make it more understandable to me. And so that's what R is. N times R, I'm doing this one. N times R times T. T is just this. So N times R times T. Okay, there's N times R times T, and that's what PV equals. But I don't want PV, I want PV divided by P, so I only have V. So I can say just V equals PV divided by P. And so we have the P from here, we have that goes there. The PV is computed, and that's there. We divide both sides by P, we just get a V, and then we can return the V. I think this will work. All right, let's see. Oh, look at that. All right. All right. Okay. Next, we're going to do, we got a few challenges or labs. So let's get through these labs. Lab training, unit test to evaluate your programming. Okay, so all this is telling you is that we are, you notice we're writing a lot of methods. Okay, we're doing a lot of stuff up here, and down here doesn't really matter so much because what we're doing down here is we're calling our methods, and our methods, if our methods work properly, we get the correct result back, and that's what gets printed out. Okay, now what they're talking about here is that in future, in a lot of these assignments, these lab assignments, they are not going to be testing whether you run it, and they're not going to necessarily be testing where they're going to give you an input and they're going to expect to see this output. Okay, that's how this textbook has been working up until now. Okay, what it's going to do instead is it's going to pull your program in as a module, and all it's going to do is it's going to have its own main program that calls your methods. See, so it's going to have its own it's going to have its own main method. It's going to call your methods a bunch of times, and it's going to pretty much ignore this part. Okay, to be able to do that, to be able to bring your program in as a module, you have to put your main program inside of an if, and it's got to be this if. What this if does is it says if the name of the main program that is executing, if the main program that is executing is this program, that's what this tests for. If this program is the main program that's executing, then execute these statements. If this thing here is not the main program that's executing, then don't execute these statements. Only execute these things up here. Only create the methods, and then some other program which is using this as a module is going to execute these methods in some way. So that's kind of what they're trying to explain to you here. So in Python labs, the line this is used to separate the main code from the functions code, from the code of the functions, so that each function can be tested, can be units tested separately. So anyway, So is there a lab here? Yes, there's a lab. What's the lab? Complete the program, which takes a weight in kilograms as input and converts it to a weight in pounds, and then outputs the weight in pounds. 1 kilogram equals this many pounds. So if the input is this, the output is this. Okay, so here we take an input, we store that input into a variable called kilos, and we call this method kilo to pounds with kilos as an argument, and it's going to return pounds, and that's going to print it out. So this thing is this is the method, takes in kilos, and what it does is it takes the number of kilos, and this thing divides by 2.2. We're supposed to be multiplying it by, supposed to return this. Instead, looks like we're returning this. So all we got to do is run it. I gotta see. Okay, so this is 10. And right now, if we run it, we get the wrong answer. Let's just run it. And we see we don't get, that's wrong. This should be multiply. And now when we run it, we get this answer, which is what this answer is. And it doesn't matter what we have up here, I don't think. I'm going to say enter number of kilos. Yeah, I'm going to say that. And I want to see if it matters. Okay, so this should still work. Oh, no, it's going to output that thing. It's going to output that. But let's see if this thing just tests this. If it does what it says, it should ignore everything down below here. I don't know if it's going to. Let's see. I'm going to submit this. Yeah. See, it didn't. It's not doing just unit tests. It's also doing the other. Let's see if I get it now. All right. Well, anyway, so that's the answer. What's the next one? Driving costs. Driving costs. Okay, and this one, we're going to have input of miles per gallon. We're going to write a function where we input the miles per gallon, and we input the dollars per gallon, and we input the miles driven, and it's going to return how much it costs to drive those miles. So you're going to input what the miles per gallon of your car is, like 20 miles per gallon, and you're going to input how much you're paying for gas. I don't know, $5 a gallon. I have an electric car, so. And then how many miles you're going to drive, and we're supposed to return how much money it costs. Did I go over this problem in a previous video? Well, anyway, so we're supposed to write the whole function. We're supposed to write it here. Okay, so if we have, let's see if I can do this again. Let me open up this. Well, I'll tell you what, I'm just going to try to type it. If we have, so it's going to be def driving cost, and what's going to oh, we're supposed to write the whole dang thing, huh? Okay, so it's going to take in this stuff like that, and we're going to output something. Okay, down here we have to input these things, so we're going to say, and I'm going to go ahead and do this, equals equals, and this is going to be miles per gallon. That's going to be a 15. I'm going to say it's an integer number, and I'm going to input it. And the next one is going to be, this is the price of gas. So that's going to be a floating point number. And I'm going to input that. And the last one is going to be how many miles you drove. And it looks like, oh, wait a minute. Okay, so we're not inputting how many miles you drove. We're gonna have that miles driven is gonna be a argument to the function, but it's not gonna be something that we're gonna read in. We're not gonna read it in from the user. We're just gonna read these two things in from the user, and then we're gonna print. We're going to print driving cost of miles per gallon, comma, dollars per gallon. These are the arguments going in there that we just asked the user for. The user just gave these values to us. And then the first time I'm going to do it for miles driven of 10. And then 50, and then 400. So I'm going to do, first one is going to be 10, and then I'm going to print out 50, 100. Oh, 50, 10, 50, and 400. 10, 50, and 400. All right, and so I got these three things coming in here, and I want to so I want to end up with a dollar amount. So it's going to be it's not, let me see. Oops. Okay, so I've got this thing here. All right, so we have like 20 miles per gallon, 20 miles per gallon, and we have $5 per gallon, and we somehow want, oh, and then we have 10 miles. We have 10 miles, and we want to put all those together. We want to put the 20, the 5, and the 10 together, multiply, divide, to end up with dollars. And precisely for 10, we want it to be $1.58 with these other numbers. Oh no, not with these numbers. But what I'm going to use these. I'm going to use these numbers. So let me just go $23.15. I'm going to do. And the third one is 10. Okay, so this is going to be $3.15. Okay, so so we have miles per gallon, and we want dollars. dollars equals, what if we do miles per gallon? 20 miles per gallon divided by 10 miles, 1/10 miles. And then we can do what's we want dollars on top. This thing is dollars on top, gallons on the bottom. This is 20 miles per gallon. So this is going to be, if I cross these out, it ends up with a 2 on top. Let me just. So this is 20 over 1/10. That's going to make the miles the cancel, and so it's going to be end up being, this is going to be 2, because it's 20/10 is 2 1 over gallons. And so if we flip that around, it's going to be 2 over gallons equals 1/2 gallons. Okay, and we've got 15. We've got $3.15, $3.15 per gallon, and so if this, we have 1/2 gallon, because when I did this calculation, I took the 20 miles per gallon and I divided it by the 10 miles, by the miles. Anyway, so then this ends up being, so I take this 1/2 or 1/2 gallons times $3.15 per gallon, and then the gallons cancel, and so I end up with 3.15 divided by 2. Well, can I somehow make this one? So 3.15 divided by $2, and that equals 1.58. 3.15 divided by 2 equals 1.5. Actually, it's 1.575. Okay, $3.15 divided by 2 is $1.57.5. Okay, so my calculation is right. Well, what was my calculation? It was miles. It was the miles per gallon divided by the miles, and that ended up with 1 over gallons. And then I had to flip that around. I had to flip this around to get gallons on top. So here, when I divide this miles over gallons divided by miles cancel, and all we end up with is 1 over gallons. So I got to flip that upside down. So really what this calculation is miles divided by miles over gallons. And then we multiply that by the dollars per gallon. This times the price of the gas, which is dollars per gallon. So miles divided by miles per gallon. So what we have is the number of miles, which in this case is 10, divided by the miles per gallon, which in this case is 20, multiplied by the dollars, by the price of gas, dollars per gallon, price of gas, which in this case is $3.15. So let's go back to here. We have So let's call this, let's make this, okay, so, well, let's just do this whole equation. I think we can do this whole equation. So it's so we're going to return dollars, and that's going to equal to, first of all, we're going to do the miles, and that's miles driven. That's this top one here, this one. Miles driven divided by the miles per gallon, which is 20, divided by miles per gallon, which is 20. So this here, miles driven divided by miles per gallon is this thing. Miles driven divided by miles per gallon, and then we multiply that by the dollars per gallon of gas. So that we can multiply this by dollars per gallon. Okay, and turns out that multiplication and division is commutative, so it doesn't matter if we multiply this first and then we don't need to put any parentheses around here, I don't think. Okay, and then we're going to return dollars. Okay, I think that's it. You probably didn't understand any of this over here, but whatever. Sorry. Okay, so I'm going to try this. I'm going to put in 315.99, and I'm going to run it. What did I do wrong? I am missing these. Invalid literal. Miles per gallon. Oh, it doesn't want that to be an integer. Oh, it's because it's 20.0. Yeah, this is miles per gallon. That's can't be a period in there. So this has got to be a float. Invalid literal for this int function. It's this. Okay, so I change it to float. See, you know, I don't try to figure out these errors before I do this, and once one of my instructor evaluation or one of my peer evaluations criticized me for doing these problems when they observed me and all these mistakes, and the idea, I've been complimented for how I handle the mistakes. Students like to see how I handle these mistakes when they pop up, because they're going to undoubtedly pop up with you too. So, and I have a tendency in my old age just to let the compiler, to let the computer tell me when I'm doing something wrong. Just go ahead and hit run, and then you know, you got to get good at reading these error messages. So anyway, dollar per gallon is not defined. Well, that's because I'm calling it dollars per gallon. So this is wrong. This should be dollars. S. And it looks like we got all the points this time. All right, let's see. So I guess we do have, I'm gonna, so we actually have convert to binary, swapping variables, and Fibonacci sequence. I'll do, you know, I'll do these next time, but I think I'm gonna like not do them completely, because I want to set aside some problems where I can compare how people do on problems that I don't give you a lot of help with, or maybe hardly any help with, how that compares semester to semester. And so and I don't want to make them all hard, because you know, that's not the point. But I do want to have some problems that I don't give you very much help with, and then if you're not that good at it, and you don't do well in those problems, it's not going to affect your grade, because it's only going to be like 1 or 2 and many. But I can use those to see how classes perform from semester to semester. So anyway, so I'll cover you know, more of these next time, probably not all of them, and then after that we'll get into chapter 7. So you have any questions? All righty. So I will see you next time. Thanks for watching.